We began our year by looking at the kinematics of moving objects. Kinematics addresses the how an object moves. How is defined in terms of position, velocity, and acceleration. The tools we used to study kinematics involved plots and equations. But now we're going to transition into the dynamics of moving objects. Dynamics answers the question of why do objects move the way they do. We have Sir Isaac Newton to thank for providing us with 3 laws of motion. These 3 laws help us understand the dynamics of moving objects. The first law we want to take a look at is the law of inertia. This is Newton's first law. The law states that an object at rest will remain at rest. An object in motion will remain in motion in a constant state, straight line at a constant speed until acted upon by a net external force. There are 3 important parts that I want you to focus on when studying this law. The first one is the term inertia. We're going to talk about that in great detail in this video. The second thing I want you to remember about this law is the constant state, straight line at a constant speed. That should sound very familiar to you since it's describing uniform motion. And the last piece is this net external force. It's going to remain in this constant state until a net external force acts on it. So this law right here states indirectly that the net external force acting on this object is going to be 0. Inertia is the resistance to a change in motion. This is kind of an odd definition. You have to really stop and think about it. It's the resistance to a change in motion. It's not talking about resistance to motion, but about the resistance to changing the motion that an object already has. Let's take a look at a freight train. A freight train is very hard to get going when it's stationary. It's also very difficult to stop a freight train when it's moving. This difficulty of starting motion or stopping motion is inertia. Inertia is a physical property of matter. All matter has inertia, and this matter happens to be equal to the mass of the object. So the greater the mass of an object, the greater the inertia of the object. And we measure this inertia in kilograms. Resistance to a change in motion. Let's take a look at the 3 different situations in which you can resist a change in motion. The possible changes in motion include speeding up, slowing down, and changing directions. Resistance to speeding up. Resistance to slowing down. Remember I told you that inertia is equivalent to mass? Which has more mass? A car or a freight train engine? Who's going to resist a change in motion more? A car or a freight train engine? Resistance to a change in direction. It's the same thing as resistance to turning. You experience this a lot when you're sitting in a car going around a turn. You're going to feel this sensation as though you're being pushed to the outer part of the curve. And if you look in the direction that you think you're being pushed from, there's nothing there pushing you. So what's happening? Your body is attempting to go straight. So as you make a left-hand turn, your body feels a sensation as though it's being pushed to the right. That's because your body is trying to continue to move in a straight line at a constant speed. It's trying to obey the law of inertia. Flowers in a vase resting on a table, bowling ball rolling down a lane, space probe traveling into deep space. All of these are examples of uniform motion and demonstrate the law of inertia. All objects exist in one of two states, a state of equilibrium or a state of non-equilibrium. If you're in a state of equilibrium, then your motion is uniform. Also, the net force acting on you is equal to zero. Newton's first law is the law of equilibrium. Remember this. I keep talking about this thing called a force. What is it? I wish I had a real sophisticated definition for you, but I don't. It's simply a push or a pull. But there are two categories of forces that you now need to be aware of. And also a variety of different types of mechanical forces. And these forces are usually based on the situation in which they're being created or the object that is creating the force. So to give you greater depth and understanding of the types of forces, I would like for you to go to the physics classroom on the internet. And then on the left-hand side, you should be able to find a unit called Newton's Laws and go to lesson 2. And on that page, you're going to see the two categories of forces. And I want you to put the two types of categories in your notes or in your journal, and also create a catalog of the different forces that are listed there. The one thing you're not allowed to do is to print the web page and just paste it into your journal. And I just realized there should be an E right here. As we study Newton's first law and second law and third law, one of the things that you're going to have to do is to develop an eye to identify the forces that are acting on an object. Pretty soon I'm going to place an object before you in a certain situation and ask you to draw what's called a free body diagram. You're going to identify the forces that are acting on the object and draw those forces in the diagram. But sometimes you have a tendency to draw a force acting on an object that just doesn't exist. So one of the things I want you to do is remember this question: what is the agent? If you have doubt about whether or not a force is acting on an object, then ask, what is the agent? What is the agent responsible for creating this force? And when I say agent, I'm talking about what is the object that is creating this force. If there is no agent, if there is no object that is creating this force, then that force just doesn't exist. It's like you riding in a car around a turn. You feel like you're being pushed to the side, but you're not. If you look to the side, there is nothing there pushing you. So that force does not exist. Another common example of what is an agent is if we take a baseball, okay, and it's been thrown through the air. And this is the motion of the ball as it travels through the air. And a lot of times students want to come in and say, okay, well, there's a force acting on the ball right here because it's moving in that direction. Well, there was a force originally to set that ball in motion, but now since that ball is moving, does that force exist? Can you tell me the object that is pushing on the ball at that very moment as it is flying through the air? There's nothing touching the ball. There's nothing pushing it. So in that situation, there is no force. And this is an example of what I mean by asking the question, what is the agent? What's responsible for creating that force? There is no agent in this situation. This concludes our lesson on the law of inertia, Newton's first law. This has been an MKL production.